Guys, well, it's final mass review part one for grade 8. You will find all the rules of math 2 for exam. Okay? Please concentrate and be ready. Okay? And every rule you have to learn by heart. Okay, let me start. First, we are going to talk about string of length. Surface okay, and that means, as you see here in the figure, we have two parallel lines, and between them we have two parallelograms A, B, C, D with red color, and another one A, B, C, E. Okay, this one. These two parallelograms are equal in area because they have common base, BC, and they are included between two parallel straight lines. Okay, next one. Uh, the first one is many this one has a equal in area equal. Here, for example, parallelogram ABCD is angle ABCD constructed on the 15th. They are also between two parallel straight lines. So the area of parallelogram equals the area of third. Next one, parallel 2. The area of parallelogram equals the area of 200. Area of parallelogram equals 10. Going to another number 3. If we look at the figure, we will find three parallelogram and I divide them in the figure are equal in also for they have the same basis and they are included between two parts of the side. So the parallelogram will be and find an straight line while the other parts will be the area of parallelogram going between parallel number 4 and half of the parallelogram is equal to 1 of here we have a parallelogram ABCD and its base is BC. On the figure, we have a triangle in very time. So the area of the triangle BCD is half area of parallelogram ABCD. Base is focus and between two parallelogram. Area of triangle equals half area of the parallelogram. Corner number 5, the last one. The area of the triangle is half base of A multiply theorem number 2. In theorem number 2, two triangles which have the same base and vertices opposite to this base are on a straight line parallel to the base have the same area. And that means if we have two triangles like ABC and DBC, they are constructed on the same base BC. They are included between two parallel lines AD and BC, and the base is one of them. So areas must be equal also. Area of triangle ABC equals area of triangle BCD. And also, if you want to say triangle ABD, triangle ACD are equal in area also, it's okay. Or they are equivalent. The meaning of the word equivalent, they're equals in area. Corollary number one for theorem two. Triangles of bases equal in length and lying between two parallel straight lines are equal in area. It means here if we have two parallel lines and we have many triangles, okay, as the yellow, the red, and the green. If the bases of the triangles are equal in length, the areas of the triangles are equal too. They are equivalent triangles. Corollary number two, the median of the triangle divides its surface into two triangular surfaces equal in area. Here we have a triangle ABC and AD is a median, so I can say I can deduce the area of the triangle ADB is equal to area of triangle ADC, and each of them equals half area of triangle ABC, the mother point. Corollary number three, triangles with congruent bases on one straight line and have a common vertex are equal in areas. Here, such a case like this, we have two triangles MBA and NCD. The two bases are equal in length and they have the same vertex above. So the bases are equal, the heights are equal also. So the areas are equal to area of triangle MBA, area of triangle NCD are equal. Theorem number three, if two triangles are equal in area and drawn on the same base and one of side of it, then their vertices lie on a straight line parallel to this base. I want to say here we have two triangles ABC, DCB, if they are equal in area, so the straight lines AD and BC must be parallel because the two triangles is constructed on the same base BC. Okay, once again, uh, if the area of the triangle ABC equals area of triangle DBC, okay, then the straight line AD is parallel to straight line BC. And now we have areas for some geometric figures like rhombus, square, rectangle, trapezium, and triangle also. First one here is rhombus. The perimeter of the rhombus is length of side multiply 4. The area of the rhombus is side length multiply height. Or the area of the rhombus is half the product of the two diagonals. Once again, the perimeter of this uh, rhombus equals 4 times side like AB. And the area is uh, side length by height. If you draw perpendicular from here, it will be a height and take it, multiply by BC to get the area. Or in another way, you can multiply the two diagonals, then multiply by half to get the area. Once again, areas of some geometric figures. The area of the square. The perimeter of the square is side length by 4 as in rhombus. The area of the square is side length by itself. It means L square, L power 2, and the area can be reduced from half diagonal square. So we have two rules here for the areas. either side square or half diagonal square. This is for the square. Once again, trapezium or trapezoid. The trapezoid, as you see here, it's a quad with two opposite parallel straight lines, like ABCD. The two sides AD and BC are parallel, and about the area, you can say the perimeter first, the sum of the lengths of its sides. We have four sides here. Don't include, please, don't include the perimeter of trapezium is the sum of AB, DC, AD, and BC. About the area of trapezoid of trapezium is length of middle base multiply height. Length of middle base multiply height. Once again, the length of the middle base is the average of the two parallel bases, AD and BC. Okay, length of the middle base equals half the sum of the two bases, the parallel two bases. About the area, we can say it is half multiply the sum of the two bases, B1 and B2, then multiply by height. Average base times height. Next one, parallelogram. The area of parallelogram is the product of the base length, and corresponding height. Area of parallelogram ABCD is either BC multiply H1 or the smaller side, the smaller base AB multiply the long height, it's H2 or TE. Once again, area of parallelogram equals the product of the smaller base and greater height, or the product of greater base and smaller height. Is it clear now? Last one, I think, area of rectangle. Okay, we have here area of rectangle with length L and width W. The rectangle area is the product of length and width. Area of rectangle is the product of length and width. The perimeter of the rectangle is double the sum of length and width. Length plus width, all times 2. Okay, once again, area equals L times W. The perimeter equals L plus W. Here we use multiply, and the second is plus for the perimeter. Okay, and don't forget, please, 2. I think this is the last slide about area of triangle. The area of triangle equals half the product of base and height. Area of triangle is half multiply base multiply height. The perimeter of the triangle equals the sum of its sides length, the sum of length of its sides. Here in this triangle, we can multiply the base, its part, and the height. Okay, because here is obtuse angle and the height now is outside the triangle. I think this is for all today, and waiting tomorrow, inshallah, for second part. See you again. Thank you so much for your watching and supporting here. Hope you will do good in your exams, and goodbye. Bye guys.